Hello everyone, today I'll be showing my solution for the Jane Street puzzle for October 2024. It's called Night Move 6. So you're given a 6x6 grid that looks like this, and each tile on the grid has a letter on it, A, B or C, and you can assign the values of A, B or C to any integer. And then you want to make it two trips, one from the bottom left A to the top right C, and one from the top left A to the bottom right C. In these trips you're only allowed to move in the ways that a knight in chess can move. You start at position A, and you start with a score equal to the value you've assigned to A. Then if you move to a same letter, so say you move from A to A, you add to your score the value of A. However, if you move from one letter to a different letter, so you go from A to B and you've assigned B the value of 5, then you multiply your existing score by 5. And you want to go from A to C with a total score in the end of 2024. And you want to do this once from the bottom left to the top right and once from the top left to the bottom right. The output that they want you to return is values of A, B, and C that work, and then two trips from the bottom left A to the top right C and the top left A to the bottom right C, showing the steps you took in order to get the two journeys. You needed to get A plus B plus C totaling less than 50 to be considered for the leaderboard, and then there was a special section for people that had a smaller A plus B plus C values. A, B, and C are all distinct, so you can't have duplicates between them. So actually the lowest possible score would be 6, which is 1 plus 2 plus 3, where either A, B, or C is 1, or 2, or 3. So here's the example they provided. You can see A is equal to 1, B is equal to 2, and C is equal to 253. So we start at A1 with a score of 1 because A is equal to 1. Next we move to B3, and because we're moving from A to A, we add this value of A to the score. Then we move from A to B, so we times our current score by the value of B, so we times it by 2 to get 4. Then move from B to B, so we add 2 because we're moving between two of the same tiles, and B is equal to 2. Then move from B to C, and we multiply it by 253 because they're different. Then we go from C to C, so we add 253, and then we go from C to C again. And you can see that we reached the final square with a total score of 2024, so this is a valid solution. They also provide an example in the Jane Street website of going from the top left to the bottom right, but we don't have to go through it. Take a look at the solution. So we started off with a 6x6 grid. This is C++, and you can see I just hard-coded the A coordinates, B coordinates, and C coordinates. Then I used this fill grid function on the right so that we could, given an A, B, and C value, we can fill the grid with the expected value. Next, let's take a look at the main function. Started off with a best total of 51. As I said, you needed a score of 50 or less to be considered for the leaderboard. Then we have a triple nested for loops with the values of A, B, and C. I chose 47 as the upper limit in the for loop because in the worst case, a score with less than 50 would be 1 plus 2 plus 47. Next, inside of the triple nested for loop, I had two if checks. If A, B, and C were greater than the current best, we continue because there's no point checking it if we've already found a better answer. And then next we just had a distinctness check to make sure A, B, and C are all different numbers. After that, we filled the grid with A, B, and C value, and then we print it out. After this, we started a timer, which comes in handy later. We define a variable trip1 result, which is a boolean, and this will determine whether the trip from the bottom left A to the top right C was successful. If it was successful, we'll try and search from the top left A to the bottom right C. Then we have this if statement, if trip1 result and trip2 result, and A, B, and C is less than the total so far, we know that we've found a successful result and we can update the new best total. Take a look at the depth first search function that I used to find the successful results. It takes in the current row, the current column, and it takes in the previous score of the square you're on and the current score that you have as a total. Then it has a visited array to see where you've been before, and it has the goal row, the goal column. Then we have a reference to that found result, which is equal to the trip1 result or the trip2 result in the previous code. And then we have a start time. Let's take a look at the DFS code that I used, and we'll break down each section. So first off, we check the current time and see if it's taken more than the maximum attempt seconds. This is set to 10, and that's because I found that if it didn't find a result within 10 seconds, it was probably never going to find a result. And yeah, this check just really helps speed up the program by a lot. Then I have this if found return variable. So this means that if we've already found a successful trip from A to C, the problem statement doesn't actually state that it needs to be a short trip or anything. So any trip is good enough and we can just exit out. I really like this kind of pattern of using a reference to a global variable. This is the trip1 found here is actually the trip1 result. So all the different DFS stacks that are running right now will check this global found result via the reference. So I find this a really useful pattern. It's probably not a good one because I don't see anyone else use it, but for me it really helps get the job done. It's a bit quick and dirty. Next we get the current value of the grid, which is just the grid value at our current row and column, and then If the score at the current square we have is the same as the previous one, that means we've gone from, say, A to A, then we plus equal the current score. And if we've gone from a square, say A, to something that's not A, and we multiply it. Next, we add to the visited array and say, okay, we visited the square now, so we don't visit it again for this trip. And then we check if the score's over 2024. Since the value will only get bigger because we're either adding to it or multiplying it by a positive integer, we can just return because we know we're never going to reach the final score, the score of 2024. Then in this code block, I check that if we've reached the goal row and the goal column with a score of 2024, we know we have a successful trip. So we can update the best journey, which is another global reference I have, which keeps track of the best trip so far, so we can print off at the end. And then we update this found variable to true. And as I said, this is a reference to kind of a global found result. Here's the DFS meat and potatoes. So for each of the possible moves, you can see in the bottom right, I've just hard-coded all the possible knight moves. There's 8 of them in total. And if we haven't visited before and it's inside of the grid, we'll do a new DFS to this square. Here's the total main function. We have these two functions at the end, print journey, which just prints out the result in the expected output that Jane Street wants. And in the end, I got a total score of 6, which is actually, the optimal result, as I said earlier. Let's run the code, see that it works. Compile it, run it. And finally, it's completed now, and you can see here's the result. Thanks for watching.